now we look at question 6. And question 6, to solve this, it might not be immediate what we want to apply, but we're actually just going to follow up on question 5 and use the squeeze theorem again, right? So this looks like a function that for now, right, if I plug in 2, I wouldn't really be able to determine the limit of, right? So for example, if I plug in 2, I would get square root of 0, right, from technically the right side, so that's fine. Root 0, we get 0. But then you'd multiply by cosine of 1 over 0. Cosine of infinity, we don't know, right? So cosine is going to oscillate as we go towards infinity. I won't know what location I'm at. So right now, this limit, we're not able to evaluate by hand, right? We would have no idea how to kind of get these. So what that means, right? We got a bunch of question marks. What in the world? How am I going to do this? Well, this is where the squeeze theorem is going to come into play, right? So the squeeze theorem can help us, especially with trig functions like sine and cosine. It will help us to figure out how to solve these limits by bounding our function by two others, right? By squeezing our function in between two other functions. So we start off as we would always do, where I take my cosine and I say that I know that cosine is always going to be bounded by -1 and 1, right? This is known for us, right? We think about even the unit circle. The unit circle only goes -1 to 1, left to right, right? For our x values, our cosine values. So if this is true, this is only part of my expression, right? Now I need to build up to get the full expression, right? The full value here. So I'm missing the root x minus 2. What I'll do is I'll multiply all of our pieces by root x minus 2. Okay, this would be negative root x minus 2. On the right side, it's positive root x minus 2. Now the question is, I want to go ahead and see if I can find the limit of the left and the limit of the right. Okay, if I can get the limit of this and this to be the same, then I could, using the squeeze theorem, figure out what the limit of this is, right? So what I'm going to say is I'm going to say using the squeeze theorem, I determine the boundaries of my function versus the others. Now I'm going to take the limit. So I'll say since the limit as x goes to 2 from the right side of negative root x minus 2. What's the limit of this? Well, plug in 2, root 2 minus 2 would be root 0, which is just 0. Whether there's a negative outside or not, it's going to 0. And that's equivalent to if I go limit x approaches 2 from the right side of positive x minus 2, right? Both of them are going to 0. We've seen that here. Therefore, since that's true, we know the limit as we go to from the right side of the function that's bounded in the middle, our root x minus 2 cosine of 1 over x minus 2 would also equal 0 using the squeeze theorem. Okay, so as you can see, it might not be apparent like question 5 was, where they give me the inequality and you know kind of the two functions that you're going to have to bound it by. You might need to create those, right? And we've done plenty of that as well, so we should feel hopefully somewhat confident in following this procedure here, where I start with the cosine, I bound it by -1 and 1, and then I start to build up all the other pieces of the function from there. Okay, so that's our question 6, squeeze theorem. On to the next.